Good afternoon, all of you. A warm welcome to all the students, faculty, and our uh, speaker for the day, Ms. Sumanta Priestley. Uh, I would like to welcome each and every one of you. Ms. Sumanta Priestley is a lead data engineer at Vehicle Data Solutions. She has a span of 12 years of experience in the IT industry. Her expertise in building scalable data solutions that will enhance the decision making and which helps to enhance the business value. Uh, she has a good expertise over this. She has an experience working over various cloud technologies, including Azure, AWS, GCP. And Sumanta is also a certified professional Scrum product owner and a certified Google Cloud professional data engineer. This shows her commitment towards excellence in agile project management and data engineering. And as a lead data engineer, she is going to give or deliver a guest lecture on insights on the role of data engineering in data science. So over to Ms. Sumanta for the presentation. And I request all the students to be attentive to the session and get a deep insight on the data engineering, as well as you feel free to ask any question after the end of the session. Over to Ms. Sumanta.
Yeah, thanks, ma'am. Thanks for the wonderful introduction. So it's a pleasure being back in Karunya. So I did my BTech and MTech from Karunya University, and it's so nice to be part of Karunya again. And ma'am had already introduced, so I work as a lead data engineer with Vehicle Data Solutions, and it's a company which works completely on data engineering, and everything related to data analytics, data visualization, and so we take a lot of projects and work on data. So that's what we are mostly into. And talking about my experience, I have worked on different kind of systems where I've done application development, I've done mobile app development, I've done data engineering, database management, and a lot of things. But all that which really helps me to stay motivated and interested is data. So I love working with data engineering, data science, and that's where I am. And I'm so happy to share the work that I have done in the industry on the data side, and I hope it will be of great help, and it's useful for the students. So let me share my screen and we'll get started. Are you able to see my screen?
Yes, ma. Yes.
Yes. Okay. Okay, so the agenda for today will be introduction to data engineering, or an overview or idea of what data engineering is. And I'll also be walking you through a data pipeline as to how data pipelines are being built in data engineering. And we'll be talking about feature management, how features are managed, because that's the main thing that gets consumed by machine learning algorithms. And as data scientists, you'll be using more of features. And we'll be ending with a real world example as to how data engineering helps with feature management, and how that impacts the machine learning models, and how it helps in driving business values for the companies. So first is data engineering. And what is data engineering? Data engineering is basically anything that involves in the design, development, and maintenance of systems, which helps in ingesting data. Basically, data, you get data from an application, or you get data from IoT devices. You can get data from any kind of system, right? Even from social media, from a lot of sources. You have a lot of sources for ingesting data. So getting all this data ingested, processing the data, storing it, and making it in a useful form for analysis or for building machine learning models. So this part is data engineering. Okay, the complete system you design, develop, and maintain. And as part of this, you'll be creating data pipelines. You'll have to do create databases, and also decide on all the different transformation processes that you'll be doing to maintain and to have a better quality of data, which is more useful, and where the business can get insights from it. So that is what is data engineering. Now, these are the key components of data engineering. So first thing is building data pipelines. Now, what is a data pipeline? Data pipeline is something like, you have data coming in, right? It can be any source system. It can be, for example, let me take a company has a data in their on-premise, meaning their own infrastructure, they have the data. And now as they plan to move that data into cloud, okay, so their source will be their on-prem server, and the destination will be a cloud, be it any cloud. They choose AWS or Azure or GCP. So as part of moving the data from the source to destination, maybe they'll also want to do some kind of transformations. They want to make the data more useful, or if it was a very old system, which was there on the on-prem, and they want to make it better. Okay, they'll have a lot of transformations, a lot of business rules applied. So all that part, right, from ingestion to reaching the destination, you have a data pipeline created. So you have a piece of the component which will just work on the ingestion part, and then another part which will be doing all the transformations, and then another part which will just load the data into your destination. Okay, so this entire piece, okay, all this combined together, orchestrated, is called a data pipeline. So as part of data engineering, you'll be building this complete data pipeline. Okay, and you'll be designing databases, because the client is just going to tell you that this is our database, okay, and this is our inflow of data from different sources where they get data from, and they'll just give you this requirement. So now based on this, you'll have to design your database such that it's going to be a good performant database, okay, because in future you're going to get large volumes of data. It should be able to handle the performance wise, there shouldn't be any dip. So based on all that, you'll have to plan the database design as well. And then the next thing is the ETL or ELT. So ETL is extract, transform, and load, and ELT is extract, load, and transform. So there are these two things which you can opt for. So extract, transform, and load is basically you extract the data from the source, and then you perform some transformations on it, and then you load it to the destination. And the other thing is ELT, where you extract, and then you ETL is extract, transform, and load. So you extract, transform, and then you're loading. In the other case, you're loading it and then you're transforming. So for example, you already loaded to a database, and then you perform transformations after the data is loaded. So these are the two different processes that you can opt for as part of the data engineering. It all depends on your requirement, what the client wants. So all these processes you'll have to decide as a data engineer. And then next comes the data quality and governance. So there's you cannot compromise on the data quality, especially when you're working on a project with client, any project be it. Okay, so the client will expect your data quality to be in par with their expectations, like good standards which can be consumed for their visualizations, for their reportings, for their machine learning models to build some recommendation systems or for predictions. So they should be able to rely on the data that you've built. It should be of high quality. There shouldn't be any issues with the data. And also governance. So governance is basically like you're working with a banking client. Okay, so there'll be a lot of regulations and rules that you'll have to follow. And similarly, if you're going to work with a healthcare has a lot of rules and regulations like HIPAA, and especially if it's US clients, there are a lot of regulations like you cannot share the client's personal details, so it all has to be masked. So there are a lot of things, and only if you implement all this, it'll even pass all the checks that the client will expect you to have. So data quality and governance is also going to be an important part in your deciding your pipelines or whatever part you're going to do. So it depends on the client that you're going to work on and what governance you'll have to implement. Okay, and the next thing is scalability and performance. So scalability and performance is another thing which you'll have to keep in mind when you're building the data pipelines, because you never know when the load is going to be high, right? For example, if you're going to be working for a client, for example like Amazon, okay, during festivals, right, you're going to have spike in the load. Okay, so your solution should be able to handle that. Okay, and the performance should also not go down. And same way, like sometimes the system can be like not be using much of your resources. So in that case also your system should be able to handle. In that way you should be able to save costs. Okay, and you don't have much resources running on cloud unnecessarily, where there's no transactions happening. So when you design your entire data engineering pipeline, you'll have to keep all this in mind, where you'll also have to think about cost. You'll have to think about scalability of your solution when there's a high demand, or when there's going to be a large inflow of data, and also about the performance. So usually performance, when they say they expect the results to come in just few milliseconds, so that's what they expect. So uh, all this has to be in your mind when you build your data pipeline. So this is one of the data pipeline that I had I had tried to make it more generic so that you can understand, but this was one of the data pipeline that I had built for a client. Okay, so theirs was from an on-prem to cloud, but I have made this generic so that it can be any source. Okay, and data pipelines can differ. It's not that you'll have to follow this data pipeline. It depends on the requirement of the client. It depends on what they need and what kind of transformations they need. And if it also depends on the cost, you'll also have to plan in that terms, like what services you'll have to use to reduce cost. And if it's going to be huge volume of data, or if it's going to be very critical data, so based on all that you'll have to decide on different services that you're going to use. And the entire pipeline itself is built based on the requirement from the client. Okay, so I'll just start from the source. Okay, so this is the source from where you will be getting data. And before talking about source, I just wanted to talk about there are two types of data that can be ingested. Okay, forget about the source. It's about how data can come in, right? So it can either come in as a batch. So batch meaning you have the data in a database. Okay, so you can just pull the entire data from the database, or you have it in a file. Okay, so you can just take the file, ingest it, and start processing. So that's kind of a batch processing. That kind of the data ingestion is called batch data flow. Okay, and then the other one is streaming data. So streaming data is something like you have IoT devices, so you're getting data real time. Okay, anything that's coming real time will be streaming data. So it's kind of you'll have to process as the data flows in. And batch processing will be like once a day, or it'll be like scheduled for us once, like that. So batch processing is something that you'll be scheduling, and that the data will come in as bulk. But in case of streaming, you can expect the data to come in anytime. It's just real time data, and you're working with real time streaming data. So these are the two types of data that you can expect as a source. Okay, and there are different sources, right? You can have a relational database or NoSQL DB. Your source can be a data warehouse, it can be a data lake, it can be APIs, it can be from file systems, it can be data streams, it can be your logs and events from the application, it can be from different cloud service providers. So basically your source can be anything. So before you start, you need to understand what your source is. That is something that you'll have to understand from the client, as to what are the different sources they're going to get data from. And most of the time it's going to be multiple sources, like they'll have a data in SQL DB, they'll also be getting data from APIs, they'll be getting sending data as part of as files, and also like streams. So usually it is some 4 5 data coming in from 4 5 data sources. So this is the first thing you'll have to understand, like what kind of data is coming in, and what is the data source. Based on that, you'll have to build your data ingestion pipeline. So the data ingestion pipeline is like you'll have to have a different component, right? In case you're going to have data getting pulled in from a relational DB, the way you pull it will be different. And if it's going to be API, or if it's going to be streaming data, it's going to be different. For example, say if I'm going to pull data from flat files, okay, the file might reside in a storage service in cloud, or it can be even on their on-prem server. Okay, so I'll have to try to consume that file and it can be, I have to understand what kind of a file it is it CSV file, or and I'll have to understand, and based on that I have to do my processing. If it's going to be a streaming data, so streaming data we can use, there are a lot of services available on cloud, like Kinesis or Apache Kafka. So those kind of services handles your streaming data. So once you try to ingest the data and figure out what kind of data it is, if it's structured or semi-structured or unstructured, based on that you'll have to write your code to get the data. Okay, and then you'll just be storing it in the raw layer. So that's this layer where you will just get the raw data consumed, okay, and then store it in the raw layer. So now I've just given some samples, okay, examples of the services on different cloud. Maybe there are a lot of services, you can use any service based on your requirement and based on the client's need. So this is Azure Data Factory. Data Factory is also a tool like where you can ingest data and do all the transformations. Okay, and similarly in AWS it's AWS Glue, and in GCP you can use Dataflow. But it's not that you have to restrict to these three services. You can use any, there are a lot of options in each of the cloud provider. Okay, so you can use any of it to do the data ingestion, and then you store it in the raw layer. So when it comes to the raw layer, again, you'll have to decide where you're going to store it, and most of the time it's going to be your cloud storage. Okay, so like S3, you must have heard in your cloud papers, right? You would have learned about AWS, Amazon S3. So S3 is also like you store your all your objects, any objects that you get in, you can just store. So why we need this raw layer is because you're trying to get the data from the source, from the client system, and you're going to store it as such in the raw layer. Okay, so this will be helpful because in case down the pipeline, if at all something goes wrong, or if they say like this was not how the data was, you can anytime point them to the raw layer and say like this was how we got the data. So it's very important to store your data as you receive it from the client, okay, as you receive it from the source, and store it in the raw layer. And you can decide on where you're going to store. Okay, and most of the time it's going to be a cloud storage, because you don't want to spend a lot of money on storage, because you're just going to store it there, right? And you're not going to directly use that data, or you're not going to pull reports or anything from the raw layer. So you've got the data from source through the data ingestion pipeline, you've stored it in the raw layer. The next step would be data transformation. So in data transformation, you will be doing all the, from basic till all the transformations that are required at the on the raw data. So you'll be doing all the data cleansing, you'll be doing all data validations, you'll make the data standardized, and any business logic and rules that the client wants you to apply, so you'll be applying all that. And through all these pipelines, right, you will be doing the error handling and auditing and logging, because error handling is very crucial, because in case if there is an error, okay, there has to be a notification sent, or you should do a retry of it, because sometimes when the services are down also the pipelines tend to fail. So you'll always have to focus on error handling. It should be part of your pipeline. Okay, and auditing and logging is also very important, because when you want to come back and see what happened, you need to have the logs kept stored somewhere. So you have a lot of logging services as well in on cloud, so you can use those services. And these are the things that are done as part of the data transformation pipeline. So now your data is clean, it has all the validations and business rules applied. So now you move this to a staging layer. So when you come to staging layer, right, you can either store it in a storage, or you can have it in your tables. Like you can choose a relational DB or a NoSQL DB, and you can have it in a table, because at this stage your data is almost clean, right? It's a what to say, a better format where you can even try to pull reports, or you can directly use it for a machine learning model. So it is kind of in a better state than in the raw layer. The next layer would be the data processing layer. So in data processing, what you do is basically now you have the data from the raw layer just cleansed, validated and all rules applied. But now, in case they want to build a data warehouse, or if they want to have it in a format like, say, they want to have dimension tables and fact tables. So you must have studied about dimension tables and fact tables, but just to give an intro, like what dimension tables are. For example, say your department, now you're part of computer science department, right? So you will have a department as a master table. Okay, so that will be your dimension table. Okay, so you'll have all the department names, and each of the department will have an ID. And students, like each of your student details will be part of the student table, and that will also be a dimension table. So these are all master tables. Okay, it's not going to change. And the fact tables would be something like students mark details. Okay, so you'll have your student ID, you'll have the department ID, you'll have the semester, and you'll have the different marks scored for different subjects. So this is kind of a fact table. So you will do all these kind of mapping as part of the data processing. So here you will do all the splitting of data, and make it stored, gets sorted and stored as part of different tables, as dimension tables, as fact tables. And also you will be doing the SCD is slowly changing dimensions. So what is slowly changing dimensions? Meaning, say now, your computer science department is part of it's the last building of in the university. Okay, but now maybe they change the location. Okay, so that will get updated, correct? In your database also you'll have to update it, saying the location is now this. Okay, so now what do you do with the historical data? So that is kind of slowly changing dimensions. So for handling that, there are different types of SEDs how you can handle. I can give you one example. What you can do is, you can have start date, end date for that particular ID. So whichever has no end date, that is the latest record. Or you can have a column which says active is active. So if it is Y, which means that is the latest record. If it is N, it means that is an historical data. So there are different ways you can handle. So all those kind of processing happens at the data processing stage. And then error handling, again I said, it comes across error handling, auditing, logging, and notifications. So this is handled across all the stages of the pipeline. So here also you can use either Azure Data Factory or Glue or Dataflow. So it depends on which cloud platform you are in. Okay, what is the preference of the client? And also the services, again you're going to decide based on the requirement. For example, in AWS itself, you have AWS Lambda, you have AWS Glue. So how do you decide which one to go for? Okay, so in case if it's a long running transformation, right, you have to go for AWS Glue, because AWS Lambda has a time frame of only 15 minutes. So it can run only for 15 minutes. After that, it will time out. So for any short transformations, maybe you can go for AWS Lambda. If you have any long transformations, time-taking transformations, you can go for AWS Glue. And AWS Glue, you also have workflows where you can also do the orchestration of the pipeline. So it all depends on the requirement and how much of data you're going to handle. So based on that, you're going to decide on the services. Okay. So now we have the staging layer, and it is moved to the data processing layer. And from data processing layer, you're going to store the data to your target data store, whatever is your destination. It can be a data lake storage. A data lake storage is basically you can store anything. You can store structured, semi-structured, unstructured data. Everything can get into your data lake storage. And data warehouse is I think that is what most of us would have used, where you have an organized way of data where you can query from that. And even from data lake storage, basically you can start querying. For example, if you store in S3, AWS S3, you have a service called Athena, where you can try to query the data from your flat files, even though it's stored on your S3 storage. Okay, so there are a lot of services available on cloud now. And even your target data store, again it depends on the client's requirement. Okay, so you based on whatever was the client requirement, and whatever will help the client in saving cost, will help them in better performance. All these comes into picture when you decide each of this, because the client is just going to say what is the source they want, and they'll want you to decide they'll just say like, I'm going to work on AWS. So you will have to give them a complete flow as to how you're going to ingest their data, what are your pipelines going to do, where your raw layer is going to reside, where your staging layer is going to reside, what are the services you're going to use for the transformations, and at the data processing layer, what kind of processing and you're going to do, and what will be your target store, and what is the cost saving you're going to do by choosing that particular service, by choosing that particular target store. So this is what is a data pipeline that you'll be building when you become a data engineer. Okay, as part of a data engineer, this will be your role. You'll be working in each of these stages, okay, till you reach your target data store. And once you reach the target data store, now your data is ready to be consumed, right? It can be consumed by either the reporting team, okay, the data analytics team. They can build reports on top of it, or data scientists can start using your target data store, or you're trying to load that particular data in some application. You can do anything once from your target data store. So this is basically a data pipeline. Now let's move on to feature management. So this is kind of a crossroad between a data engineer and a data scientist. Okay, because as part of data engineering, you're trying to get a clean data, a data of good quality, which handles all the rules, the regulations, and everything. So it's up to the standard now. Okay, and now the data is stored in the data warehouse or data lake, and how is a data scientist going to use this data, right? For that, what do you need for a model? Basically, it is features, right? When you come to machine learning, even if you spend a lot of time building a model, data is all that is important. Because if your data is corrupt, if your data is not of good standards, you're not going to get good results, right? So data is very important, and choosing your features and how you're going to manage that features is very important. So this is the crossroad between the data engineer and data scientist, where data engineer and data scientist will work in collaboration to do this feature engineering part of the development. So let's get into the feature management. Now, what is feature? Feature is any individual measurable property which can be fed as an input for machine learning algorithms, right? To make predictions or decisions. So you use a lot of features. You decide on what all features will be good, right? So that is what is a feature. Now, what is the importance of feature? First is the performance, right? The quality of feature is very important to get a better accuracy, right? So that's very important. You need good quality features for your model to perform well. And then feature engineering, where you select, you modify, or create a feature to improve the model performance. So what do you do as feature engineering? You already said you have data in your data warehouse. You can directly use that, right? So that's not the case. For example, okay, so if the data comes in as a timestamp, okay, now you can separate that into three separate features like day, month, and year from the particular timestamp. Maybe the day will influence, or the month of the purchase, or anything will influence the year. So each of this becomes a feature. So all this is handled as part of feature engineering. Okay, for example, even what to say, maybe the year of construction of a building will come uh, as a data stored in the data warehouse. But as part of your feature engineering, you will need the how old the building is, right? The number of years it has been since the building was constructed. So that kind of thing, where you select the data from the data warehouse, but you do some modification, or you create a feature out of the data which is there in the data warehouse. All this is tackled as part of the feature engineering. Next is the feature selection. So you'll have to select the most relevant features for your model, correct? So that is also why the feature engineering and all this feature management is very crucial. Now, when I'm going to talk about this, again, it's going to be a little aligned towards data engineering. I'm not going to get into details of machine learning, or how the machine learning models are going to consume it, but I will just take you through how the data is being handled, how data engineering and feature engineering helps in, getting your models perform better. So it's going to be in that flow. Now, what are the challenges in feature management? Okay, so first thing is the features are not available. That's the first challenge in any team you ask. That will be the first challenge that companies face, because they have multiple projects, multiple teams running, and each of it manage their data warehouse separately. So now, for example, I work for a project, okay, within the same company, but I want access to a different data, okay, from the same company basically, but a different project. I will not have access to it. Okay, but actually the features that they have developed, I will need the same features for building my as inputs for my model, which I'm going to use in as part of my project. But since I have no access to that particular data, I'll have to redo everything. And there are a lot of chances that the workflow that they follow and we follow will be different. Okay, and that results in the way the data gets processed itself will be different. The data itself might change. Okay, so we are not being consistent across projects within the same company. So this was a great challenge in feature management. Okay, so for that only mainly they started using all this trying they started trying to use kind of any better feature on cloud where they can do this feature management, where the clients or the projects can reuse. Okay, so the first thing is the data being scattered across teams, and the next one is the reusability. Right, so one project has already spent a lot of time building that particular feature, doing all the part of the data engineering and the feature engineering, but we are not getting it reused, right? And the other one is versioning. So sometimes the workflow itself changes, so you update your workflow, and all of a sudden you want to know how your data was previously, just one version before, or you want to if something goes wrong with the model, you want to get into your previous version. How do you do it? You don't have any versioning, you don't have your data, you have it's all lost, right? So for that also, that is also one of the biggest challenge. And then quality. So quality is like every data every team uses should be of high quality, it should be consistent. So these are the different kind of challenges that the companies face in terms of feature management. So for that, to overcome all that is what is the feature store. So feature store is something which is being predominantly used across companies now for maintaining the features. So what is a feature store? So it's a central repository for storing, managing, and accessing features. Okay, and this can be shared across. So it's kind of really useful because now the teams can start using the same set of features. I'll just walk you through the feature store. What happens? So you're going to get data from the data source. Now you have your data stored in your data warehouse, or it can be a streaming data already processed, transformed. It's already in a usable form. Okay, so that is going to be your data source. And now you're going to do feature engineering. So I spoke about what we do as feature engineering. You're going to try to create, modify, or uh, you know uh, do all select what kind of features, all that you're going to do as part of feature engineering. Now once you do that, once you have a pipeline which is built to do all that, your features will get stored in a feature store. As part of feature store, you'll have two stores. You'll have an offline store and you'll have an online store. So for all the data that comes in, right, is going to first get into your offline store. So what is an offline store? Offline store is basically you have all your data. Okay, it's going to be a vast store, which would be kind of when you want to do batch processing, or even if you're going to do a real-time streaming, all the data is going to get into your offline store, and the data from your offline store is what you're going to use to train your models. Okay, so you will take all the bulk data, okay, as a batch, and that data you're going to use to do the model training. Okay, so now why do we need online store? Online store is because say you have an application, okay, and you want to do predictions on the fly. Okay, so you need it to happen really fast. So for that reasons, you're going to use the online store. So online store will have the latest data. Okay, so let me give you an example. A client, I mean, a customer is using a website. Okay, so every click of the client, of the customer, every purchase, every their browsing history, their things that are added to cart, all those is considered to be a click, okay, action by a client. So all these actions will get stored into your offline store. But when it comes to your online store, whatever is the latest action by the client, right, only those will get stored in your online store. Why it is? Because you need your features to come up really fast. So you need to have in some store, and mostly online stores will be your key value databases, where the performance of the database is going to be really quick. You're going to get the results really quick. So that's why you have the online store. And offline store will be like for your batch predictions. Okay, so for example, I say I send a customer ID, and then I say give me the score for that particular customer ID based on their actions. Okay, I give a 5 or 10 customer IDs. So in that case, it will go to my offline store and pick the data. So it is going to pick the data for all the 10 customer IDs. It's going to do a mapping. It is going to look up to the offline store and get all the features for that particular customer ID, and then it will give me my predictions. Okay, but if I'm going to give only one particular ID, one customer ID, and ask for a prediction, and I need it really quick, in that case, if it goes to an offline store, it'll take a lot of time for me to get back the results. So in that case, it'll go to my online store, it'll get the all the features for that particular customer ID, and I will be able to give that as an input to my model, and I'll be getting the inference. Okay, so that's the different offline and online store. So most of the time you'll be using your offline store, but in case your application is very real time, or if it needs uh, quick response, you're going to use your online store. And the data from your offline store is going to keep getting published to your online store. So the latest data from your offline store will always reside in your online store, but the historical data, the complete data, is always going to reside in your offline store. So this is model training, where you get data from your offline or the offline store. And model serving is basically your inference. You feed uh, the data, you give the data to the model, your features to the model, and you try to get the predictions. So that is model serving. So all these features, right, as part of the feature store, you have something called feature registry. So you'll be registering all these features in the feature registry. Now when another project or another team tries to come and understand what is there, they can just directly go to the feature registry, where they'll be having the metadata of the tables. Okay, so they know what all features are already available, and they don't have to go and build the feature again. Okay, so they can use the existing feature. And another benefit is, when you try to you're going to train a model based on a set of features, and it's going to be of a particular format, correct? So that's how your model has been trained. So when you give the data as an input also, it should be in this exact same format, correct? So you don't have time to go to get that done if you're going to do it on an offline store. So when you have an online store, you always have the features ready, and it's going to when you just give the customer ID, you're going to get all the features instantly from your online store, and it's going to be in the same format, and you can expect a better predictions, because the format of the data is also the same. So it all goes through the same workflow, right? So that is the main use of your feature store. Okay, so you have your features registered, so other teams can also use, you can share your features, okay, between teams. So all these things are the main things, or the main advantages of using your feature store. Now, I'll just give you an example of a feature store in Databricks. So in Databricks, there are two things. You can use a Delta Lake and a Unity Catalog. Okay, so these are the two services that you can use for storing, managing, and governing features across models. So if you see here, you first get the raw data source, right? And then it gets into the featureization. So featureization is basically the feature engineering. You're trying to build features, and then you store it in your offline store, which can be delta tables. Okay, so you have all the features stored in your offline store, and the features from your offline store is used for your model training. Okay, so from there, from once your model is trained, your model can start giving endpoints for your model for the users to start using it. For the client, they can directly call your the endpoint. They can give feature and they'll expect the prediction or output, correct? And all these data which is there in the offline store will also get published to your online store. So when there's a request coming in from the client for an online or real-time prediction, it will directly get into your online store, get all the features from your online store, and it will be able to give the predictions back to the client. If it's going to be a batch prediction, it will again come back to your offline store, it will get the data, and then it will be able to give the predictions to the client. So this is how a feature store will be working. So as part of the feature store, right, you'll be also having your model tracking, you'll be registering your models, and all these information will also be available to your other projects. So they know, like, which are the group, like, even if you say features, right, you're going to group the features, kind of these are the features that you're going to give as an input for this particular model. So even that details they'll be able to see the other projects, and if they want to reuse, they'll still be able to reuse the same feature. And we are saving a lot of time on this, because the other team will not have to work on doing all these work that already another project has worked on, right? And you have your feature readily available, and that way the quality of data is also going to be high. Okay, so that's what they talk about, feature discovery and reuse. So it is useful for sharing and reusing of features, okay, and also reducing the duplication effort, correct? And then online and offline serving. So it is used for both real time and batch line context for machine learning models. And also versioning and lineage. So versioning, I said, like, to track of the history. And when you talk about lineage is something like, once it enters into the feature store, it also maintains all the lineage. What do they mean about lineages? How the data gets transformed, like, from where the data came, how the data got transformed, all these information is also stored. So your source, what was the intermediate table where the data got stored, where how it got transformed to another table. So all this flow also gets stored. So that is where you have the tracking of the versioning and lineage, and integration with ML pipelines. So this part is completely machine learning part, where I'll not be getting into. So you also can integrate with your machine learning pipelines, which is very helpful for you once you have your features ready. So the next one is, this is also an example, Amazon SageMaker feature store. So similar to how we had Unity Catalog and Delta Lake and Databricks, we have this Amazon SageMaker feature store in AWS. It also almost have the same features as we saw in Databricks. It has the online offline store, it has the feature transformation validations. You can seamlessly integrate it with any AWS services. And also the main thing is on the security and compliance, right? With the Databricks as well, and even in AWS, anything. So your admin will have all the access for giving permissions to your table, whether it is a read permission or whether they'll be able to edit. Okay, so all these kind of permissions also can be easily handled from one place. So that's the main advantage of using your feature store. So I think I already talked about all of these benefits. One is the increased efficiency. Your time spent on building features gets really down now, because it's just one effort, and other teams can also start reusing your uh, the features that was developed by you. Consistency. So we ensure that the same features are being used, okay, and each team does not build up their own feature. They're going to reuse. So that makes it the predictions more reliable, and it gives way for collaboration also. So you collaborate with other teams, and it helps you to expand your knowledge as well. And scalability. So large volumes of data can be seamlessly handled by feature store. Okay, so now that we understood what data engineering is, and from data engineering, how we do feature engineering and how we build feature store, I just want to give a quick example of a real world example. I cannot, tell about the name of the company, but I can just tell you what the company did, and how we implemented feature store for that particular company, and how it really impacted that company, and how they were really very happy. Okay, so I was working for one of the company, which was they were it's a car sales company in US. Okay, so they had a issue where each of their team had data. Okay, different teams had data, but they were really not able to get all this data together in one place. And they wanted to build machine learning models, but they did not have good quality of data. They did not have the data in one place where they can directly feed into machine learning models and get the output or the predictions and all that. So that was the major concern for them. So we tried to implement a feature store for them, and I'll just tell you like how it really helped them. Okay, so the challenges in that car sales company was that the data was scattered. It was scattered again across the sales, the marketing, service departments. So they had data, but it was just across the projects. Okay, they do not have it in one place, and it was very difficult in tracking the customer preferences and behavior, because they need to know what is the preference of the customer, right? To even suggest them what they want, or which car they can buy, or even for them to know, if this customer, based on the behaviors, if they can predict if this customer is going to buy that car or not. So for all that, they need to know all the preferences, the behavior, the data related to that in one place. And they also wanted it real time, at least uh, the predictions being run once in a day, so that they have insights for sales and marketing efforts, for giving promotions, for giving discounts. For all that, they need the predictions real time. Okay, so these were the challenges faced by the company. So we tried implementing a feature store for them. So we had opted for Delta Table, which is in Databricks. Okay, and they had their data sources. So when you build a feature store, right, there are a few things you need to know, like where are you going to build your feature store, which technology are you going to use, or which clouds provider you're going to use. So first you're going to decide that, and then you'll have to understand from the client what are the sources that you're going to get data from. Okay, so even if it is CRM, website interaction, purchase history, inventory data, customer calls, so each of this is going to be a different team handling it. Okay, so their data warehouse is going to be different. Though it is going to be a cleaned data, it is validated, all business logics and all applied, like how we saw in the data engineering pipeline. We have everything done and stored in the data warehouse, but again, it stays in separate places. It's not together for you to make any like insights. You cannot draw any insights from that. So it's all kept in different places. So you need to know what are the data sources, from where are you going to pull these data from. So once you pull all these data, right, all these sources that you're going to get data, you will get all these data, and then you'll start building your features, right? So the features that we built for them was basically we scored each customer. So as we got data from all of these systems, we had different features, and based on the features, the final prediction was a score. Okay, so using the score, the company would make a decision. If the score is above, like say the score, you're going to score them between 1 to 10. Okay, if the score is above 5, then there are a lot of chances for that customer to actually buy your car and get you can make them your customer. Okay, if it's below 5, there are a lot of chances that they're not going to end up buying. So if it's above 5, and if it's above 7, if it's above 8, what are the different kind of steps you can do? Like, what are the different kinds of marketing strategies you can use? What are the different kind of discounts you can offer them to make them your potential customer? Okay, so all those kind of things that we had done for them to create features. And that feature with that features, we tried to train their models. Okay, so that which will give them the scores for the client, and based on that, they have built their recommendation systems. So this is the integration with their ML models. So once we built the features for them, they use those features to feed their ML models, to train their ML models, and they built a recommendation system where they will recommend what kind of car based on their behaviors, based on the clicks that they made online, or based on their purchase history, all these things combined. Okay, so you can suggest cars for them, which will be useful for them, right? And also predict whether they're going to buy based on the customer behavior, whether they're going to buy the car, or whether it's not. worth spending time on the particular customer. So all those kind of predictions we were able to make. Okay, so this was how the feature store was really helpful for them to feed the features into their models. So what was the impact on their business metrics? With the feature store being built and in place for them, they were able to increase in their recommendation accuracy. Okay, and they were able to improve their conversion rates. So they gave the right deals for the client, and they were able to increase their sales basically, and enhanced customer engagement. So your customers are going to be happy, right? Because you know what they need, and you're giving them the right deals, or you're giving them the right suggestions. So the customer is going to be very happy when you give them the right solutions, correct? And also for us as a client, okay, that car sales company, they were really happy as we implemented feature stores for them, because it saved them a lot of time, because now they're the projects, each of the projects individually, they did not have to build features. It was all in one place. And other thing is, it saved them a lot of cost, because each of those projects are again going to store it in a S3, or any of the cloud service, and all those services which they're going to use, they're going to pay for it, correct? So now if it's going to happen once, they're going to save a lot on the cost. So that is an again cost saving for the company. Yeah. So these were the different, and they also had better engagement with the customer. They had improved their sales. So all this made the client, for us as developers, for us, our clients are going to be the car sales company. If you make them happy, that's what is your final goal, correct? So that's how the feature store implementation was really a great success, and it really had a good impact on their business metrics. So I think I've covered the complete data engineering flow. I've covered your feature engineering, how features are managed, what is the importance of feature store, how feature store helped building your machine learning models, and what is the impact that feature store will have on your business. Okay, I hope it was a useful session, and thanks a lot for this opportunity. And now it's open for questions.
Yes, thank you, Sumanta. And it is open for questions. You can raise your hands if you have any questions, so that I'll unmute you for raising up your questions. Is there anyone who's having any kind of questions that you wanted to ask? Any doubts that you have to get it cleared? So that means everybody you have understood everything in full. And I would like to extend my heartfelt thanks, Sumanta, for your insightful and enriching session on the role of data engineering and data science. Really, it was a good talk where you have told or explained how the critical connection between engineering and data science happens, how data engineering serves as a good backbone for making good processing and management and analysis of our data. And the real-time example that you provided was also of invaluable clarity, where the data structure pipeline, scalable infrastructures, how effective management techniques will empower good data science projects. So our students are also doing data science projects. Hope they would have learned or been inspired from your experience. And thank you so much once again for sharing your time and your knowledge with us. Looking forward for much more opportunities further. Thank you so much for coming up and giving a talk to our students. Now, the feedback link is put for you all. All the students have to kindly fill in the feedback feedback for CSE separately and for the AIML students separately.